in 1564 in Italy. 1589, 25-year-old, he became the professor of mathematics at University of Pisa. 1 year later, 1590, a 26-year-old man, 26-year-old Galileo, did a famous experiment. He dropped a spear from the Leaning Tower of Pisa at 26-year-old, 1590, to demonstrate one simple thing, to demonstrate that the time of descent, independent of their masses, that the heavy object and the light object fall at the same rate, touching the ground at the same time, making Aristotle incorrect some 1900 years later. Today we're going to use those data collected by Galileo 1590 from drawing the two sphere to draw displacement versus time graph, distance versus time graph, velocity versus time graph, speed versus time graph, acceleration versus time graph, and magnitude of acceleration versus time graph. So let's dive in. So Galileo experiment lasted for 3 seconds. So we're going to do exactly the same thing Galileo did 1590 from the Leaning Tower of Pisa at University of Pisa, Italy. So let's draw a table. First we're going to find the displacement. We're going to find the displacement by using half gt squared. And then we're going to find the distance, and remember the distance is the magnitude of the displacement, and we're going to find the velocity. Velocity final is equal to velocity initial plus gt. This equation I also proved in the classroom. And then acceleration, before we do that, we're going to do the speed. Okay, the magnitude, the speed is the magnitude of velocity. Okay, and then we're going to find the acceleration due to gravity, and then we're going to find the magnitude of the acceleration due to gravity. First we're going to do the 0 second, then we're going to do 1 second, then we're going to do the 2 second, then finally we're going to do the 3 second. And at the end we're going to draw the graph. So this is our goal today. So at 0 second, how much the sphere displaced? If you plug 0 in the formula, you're going to get 0. So 0 squared is going to give you 0. So 0 displacement. The magnitude of 0 is of course 0. The velocity, this formula, if you use this formula to calculate the velocity at the 0 second, you're also going to get 0. So when you drop something, the initial velocity is 0. So initial velocity is 0 when you drop something. So you can let it to 0. So if you plug in 0 over here, velocity is 0. The magnitude of 0 is of course 0. Now here comes the acceleration. Acceleration due to gravity, even at 0 second, is negative 9.8. Acceleration due to gravity is the same regardless you dead or alive, you sleeping or you are awake, you dancing, you laughing, you jumping, you falling. What is the acceleration due to gravity here on this pen? 9.8, negative 9.8 meter per second every second. What is the acceleration due to gravity if I hide it under the table? This is still negative 9.8 meter per second every second. So acceleration due to gravity is negative 9.8 meter per second every second, no matter what. This is a constant. Okay. And the absolute value of negative 9.8, which is the magnitude of acceleration due to gravity, is 9.8. Now at the 1 second, so if we remove 0 and put 1, then we're going to get 4.9. So 4.9, but don't forget to put negative. Okay, so the magnitude, distance is the magnitude of displacement. So what is the magnitude of this negative 4.9? Is 4.9. Velocity. So velocity, if you put Vf is equal to G, which is negative 9.8, and time is 1, so you get negative 9.8. So negative 9.8. Absolute value of negative 9.8 is of course 9.8. Okay, acceleration due to gravity is still negative 9.8. Acceleration due to gravity is still negative 9.8. So negative 9.8. Negative 9.8. Okay. So then the absolute value or magnitude of negative 9.8 is just 9.8. Okay. Number 2. At 2 seconds, you plug into and you get negative 19.6. Absolute value of negative 19.6 is simply 19.6 meters. If you put 2 seconds over here, if you put 2 seconds over here, you get 19.6. So it's going to be negative 19.6. Okay, negative 19.6. And absolute value of negative 19.6 is just 19.6. And this one, the acceleration due to gravity is negative 9.8. And absolute value of negative 9.8 is 9.8. Okay. At 3 seconds, so you put 3 over here, and you get, if you calculate it, you get negative 44.1. Absolute value of negative 44.1 is the distance, which is 44.1. At 3 seconds, what is the velocity at 3 seconds? So this is negative 29.4. So 29.4. Absolute value of 29.4 is just 29.4. Acceleration due to gravity at the end of 3 seconds is same. 9.8, and magnitude of acceleration due to gravity is all. So this data collected from the Galileo dropping a spear from the Leaning Tower at University of Pisa in 1590, 26-year-old Galileo. So as you see that, a few things you see. First we're going to draw it. We're going to draw the dt gap. So let's draw the dt gap, and before we do that, let's draw the distance versus time gap. So I'm going to write 1, 2, total 6 graph we're going to do, 3, and then I'm going to do this one, going to be 1, 2, 3, altogether 6. Okay, the x-axis we always going to call it t. The y-axis we're going to call different thing at different time. So we're going to call this one is displacement. So this one is displacement, so we're going to call this one is displacement. Okay, this one is a velocity, so we're going to call it velocity. This one is acceleration, so we're going to call it acceleration. Okay, so displacement, velocity, acceleration. What is the magnitude of displacement? Is distance, so we're going to call it distance. What is the magnitude of velocity? Speed, so we're going to call it speed. What is the magnitude of acceleration due to gravity? Is just magnitude or absolute value. Okay, all right, so let's go to this one. So 0, 0, so 0, 0 is right here, all right, I'm gonna use the rate. So 0, 0, so you have 3 seconds. 1, 2, 3, 3 seconds, and you have, all right, so you have like, this graph would be like this, okay. If you plot this graph would be like this, a curve, a quadratic function. Next time we're going to talk about the quadratic function. Quadratic function first invented by Brahmagupta 700 in India, and then it was solved by Khwarizmi in Baghdad 900 AD. So, and then Galileo realized that the projectile motion creates parabola, which is quadratic in nature, and then he deduced that it is d is equal to half a t square by using the mathematics created by, some of them created by Brahmagupta and Al-Khwarizmi. Of course, I'm going to prove that in next class. Okay, now velocity versus time graph. Now, how are we going to do velocity versus time graph? So this is also going to be in fourth quadrant. So the slope of this one would be negative. And is going to be, this one is going to be linear decreasing diagonal line starting from 0. Linear decreasing diagonal line starting from 0. Okay, so this is the slope of this one. Alright, so acceleration due to gravity is, we know that. So this is a problem. This is not correct because the time cannot be negative. So be careful. It's a step from 0. Okay? Time cannot be negative. We cannot go back to time. So it's a step from 0. So this is negative 9.8. Okay? So this is the slope of this one. We're going to call it a horizontal line below the x-axis. We're going to call it diagonal line. Linear decreasing diagonal line starting from 0. Okay, now, if we take the absolute value of this one, what do we get? We get this. If we take the absolute value of this one, what do we get? We get the speed. This. If we take the absolute value of this one, what do we get? We get the magnitude of the acceleration due to gravity. Okay, now we're going to write the equation. First we're going to write using the math, and then we're going to write using the physics. Alright, so let's start with the math. Let's start using the math. So now this is going to be y is equal to, let's see, so y is equal to negative ax squared. Okay? And this is y is equal to negative mx plus b. And b is 0. And this is y is equal to negative c. This is y is equal to ax squared. A second degree polynomial, ax squared plus bx plus c. b is 0 and c is 0. Why b is 0, c is 0, I'll prove that next class. Speed is y equal to mx plus b, and the b is 0. And this is y equal to c. Okay, now we're going to write the math, the physics. Okay, so this is d is equal to half g t squared. Okay, that means a must be 4.9, or this value is negative 4.9. Okay, which I'll prove it next time. Amazing. This one second degree polynomial was invented by Brahmagupta, and it was kind of solved by Al-Khwarizmi, the father of algebra, all of a sudden used by Galileo, figuring out that, hey, the math created by Brahmagupta in India 700 and Khwarizmi in Baghdad 900 all of a sudden become useful because it can be represented to explain the natural phenomena like dropping a spear from Leaning Tower. 15. This one is VF is equal to VI plus GT. Okay, BI plus GT. VI is 0 as B is 0. BI is 0 is because when you drop something, VA is 0. And this is X. This is a number, so Z is negative 9.8. So this is D is equal to absolute value of this one. So absolute value of this one would be D is equal to half GT square. And absolute value of this one would be BF is equal to VI plus GT. And absolute value of this one is G is equal to 9.8. Next class I'm going to prove how Galileo 1590 used some of the math created earlier by Brahmagupta and Al-Khwarizmi used to model the behavior of falling body.